Lesson 9-7, linear and nonlinear functions. So when studying pre-algebra, algebra, and so on, a lot of it revolves around linear functions, and linear functions are functions that make straight lines. Nonlinear functions then are considered probably more curves, but there are other things. They do not have constant rates of change, so their graphs are not straight lines. There's three different ways that you could be given functions and you have to determine if they're linear or nonlinear. Probably the most simple would be a graph of it, and it says determine whether each group represents a linear or nonlinear function. Well, if you look at this example 1, you think that is linear or nonlinear?
Linear.
Dakota?
Linear.
Yeah, because why, Dakota?
Because it's straight up and down.
Linear, and you would say because it makes a line. Because it makes a line. Okay, what about example 2 then, Shane?
Nonlinear.
And why do you think that?
Because it doesn't make
Because it doesn't make a line. Well, if I could write, it does not make a line. Okay, so that one's definitely nonlinear. All right, questions about that? That's pretty cut and dry. Okay, let's look at the next thing. Linear functions can be written in the form of y equals mx plus b. Y equals mx plus b is otherwise known as the slope-intercept form. Okay, we've talked about this before. Now, notice a couple things about the slope-intercept form. First of all, it's got an x and a y. As long as it has one of those, it's a line. As long as it has one of those. Okay. The m and the b are numbers that represent the slope and the y-intercept. They could be any integer or fraction, any real number basically, and can even be 0 and still be in slope-intercept form. So I've got some examples of linear functions for you. If you had one like this, y equals 2x plus 1, that's in the form of y equals mx plus b, so that is a linear function. And I went ahead and did one without the x, y equals 3, that's a linear function, versus the ones that are nonlinear. So I want you to look at the kinds of things that make it nonlinear. Y equals 2x squared plus 3x. That exponent right there, definitely nonlinear. Y equals the square root of x. Believe it or not, that square root is also kind of an exponent. You haven't really studied that yet, but it's a fractional one. So that's what makes it. So no square root on the variable, no squared term or exponent on the variable, and the other thing is no variable in the denominator of a fraction. Okay, this one would also be considered nonlinear. Any of those three things make them nonlinear. Okay, putting it in slope-intercept form, that's what would make it a linear function. So let's look at a couple of those. Determine whether each function represents a linear or nonlinear function and explain. So for example 3, y equals negative 5x minus 4. What are you thinking? Are you thinking that's linear or nonlinear? Trayton.
Linear.
Okay, linear, and why is that?
Because there's no exponent or
Okay. What we might want to say on that is it can be written, whoops, if I can write, written in y equals mx plus b form. That's kind of the key, that it can be written like that. Y equals mx plus b form. Okay, what about y equals 2x squared plus 3? How about somebody that hasn't gotten a ticket yet? Tori? And why is that? Because of why?
Does that have an exponent?
Yeah, nonlinear because the x has an exponent. So therefore it can't be written in y equals mx plus b form because x has an exponent. Cannot have that. Well, it can't have an exponent other than 1, basically. So, all right, questions on that? So here's the last part. So we had graphs, we had equations. Now we're looking at tables. Linear functions increase or decrease at the same rate. Nonlinear functions do not. Check using the table. Here's what we mean by that. So you go down each column, start with the x and then go to the y, and see what the change is from one step to the next. So from 2 to 4, it's plus 2. From 4 to 6, it's plus 2. And from 6 to 8, it's plus 2. Those are all the same. So that's good. That's the same rate. Let's look at the y. It's got to also be the same for it to be linear. So 1 to 2 plus 1, 2 to 3 plus 1, and 3 to 4 plus 1. That is also the same rate. So because they are both the same rate, you would say that it is linear. Because they're the same rate on both sides, they're increasing by the same rate, it is linear. Let's look at example 5. If I go down the x column, plus 1, plus 1, plus 1. That's the same. On the y, plus 3, plus 5, plus 7. That one is different. It is not the same. So that would therefore be non-linear. That would be a non-linear function. And that's what you'd have to check.